Welcome to a new Press Plastic video. So in this video we're going to make the sheet press, finally. So the sheet press makes plastic sheets, like this one. And they are 1 by 1 meter and made from plastic. And you can play with different colors and patterns, so it's a very fun one to work with. In this video we're going to make the sheet press. You can also get a bit more efficient and really set up a sheet press system with a few other things combined to get a higher productivity. But we'll talk more about that later in this video. If you want to download all the files, you can go to our download kit. If you have any questions, go to our online community. Now, Jason is going to show you how to build it step by step.
Hey everybody, so today we're going to show you how to build a sheet press. We're going to build it in 7 steps: the pressing plates, the frame, the heating plates, the pressing mechanism, the extraction hood, and the electronics box. And finally, we're going to assemble everything and show you how it's run. I'll show you step by step how to make it, and you can find all the technical information and drawings in our download kit. We'll start by making the pressing plates. Overall, for this video, we got most of our sheet steel components laser cut to save time. They can also be cut by hand. Now let's begin with the pressing plates. So now we're going to assemble the support structure for the heat press. The pieces are made from 6mm sheet steel. We got ours laser cut, but you can also use an angle grinder to cut it from hand. These pieces have a small notch to indicate that they belong to the upper plate frame. Okay, so the pressing plates are partly done. Before we continue, we're going to assemble the frame. This allows us to align everything. Once that's done, we'll continue with the pressing plates. So when welding the bottom frame, we use the 3 jack mounting plates to space the 2 bottom beams evenly. Make sure to weld the middle plate first, as it's more tricky to access once the 2 outer plates are in face. We also put the bolt in the 3 jack mounting holes so that they're aligned when welded. So now we're going to weld the side frames and the bottom frame together. To align them properly, we're going to bolt the top pressing plate in place. Before bolting it in place, we're going to apply a layer of paint to the areas of the frame that aren't accessible after bolting. The paint prevents the steel from rusting, so every surface must be coated. So now we're going to weld the side frame and the bottom frames together. We can use offcuts from the rest of the build to position the bottom frame in place. It needs to be raised 100mm off the ground to allow for the pallet jack to slide underneath. So now that we've finished the frame and the pressing plates, we're going to focus on installing the heating elements. We're going to mount the heating elements to the aluminium plate and make the aluminium blocks that hold them in place. now we're going to drill the hose in the aluminium plate for mounting the cartridge heaters. To drill the hose straight, we made 2 jigs. To make the jigs, we need one of the aluminium blocks, which we're using to mount the cartridge heaters, an offcut of steel extrusion, some double-sided tape, and some rubber. So start by marking a square around the middle of the aluminium block. To stop the block moving around while we're drilling, we're going to put a piece of rubber on the bottom surface. The second tool we're going to make is to ensure that the drill bit stays straight as we drill into the plate. So we started by drilling a hole using the pillar drill into the piece of steel, fastening a piece of rubber onto the bottom of the steel to stop it moving around while drilling. So now we're going to mount the aluminium plates inside the frame. To position the plate, you'll need some extra hands. So we insert the mounting plate inside the groove and then fasten it from underneath. So we want to have the plate slightly lower than the steel frame. So once we've tightened it fully, we just reversed it 1 turn so that it drops down. Now we're securing the cartridge heaters inside the aluminium blocks. To do so, we used heat-resistive conductive glue. Make sure to wear the appropriate safety equipment suggested by the can. Attach the wires from the cartridge heaters to the ceramic terminals. Refer to the circuit diagram to distribute them evenly. We numbered them with which phase they belong to avoid confusion. You may need to extend the cables from the cartridge heaters. If you do, make sure you solder and insulate them with solder and heat shrink that can withstand high temperatures. Next, make the body panels for the pressing plates. Start by cutting and grinding them. You can use the mounting tabs on the pressing plates to mark the center of the hose. Next, cut and insert the insulation material. Now we're going to mount the pressing plates to the frame and make sure that they can slide up and down. For this, we need to build a sliding mechanism and a spring mechanism for the jack. You're going to need an 8-ton jack, M16 bolts, M16 washers, M16 nuts, some steel tube and some steel stock. The tube and the stock should run smoothly inside each other. You can use the leftover material from the previous version's injection machine. We also laser cut some components from 6mm sheet steel. And finally, you'll need a spring. So the size of the spring can vary slightly. You need to adapt the size and the position of the washers when you weld them. We used a die spring, but you could also use a spring from a motorbike or a car. You just have to make sure that it's very stiff. For the butter jack, we used a manual one, but you can also use a pneumatic one, which will make pressing faster. You need to make sure that it has an eye connection instead of a plate at the bottom, so that you can fasten it to the frame. So let's start by making the spring mechanism. Next, we're going to make the sliders. Start by cutting the steel tubes to size. Weld and grind the tubes. Leaving the bolt slightly loose allows the sliders to move, which prevents them from jamming when pressing. So now the heating plates, frame and sliding mechanism is finished. The bottom plate should be able to slide up and down. Okay, we're almost there. Next, we're going to build the extraction hood. Before melting plastic, make sure to check out our video about fume safety. We're adding a hole on the top of the hood to attach the extraction device. Make sure to make it fit your extraction system. Assemble the plywood sections and temporarily fix them with tape. Okay, final part, electronics. We're going to put all the electronics together in a control box to make the press work. First, weld a box from sheet metal and protect it using a layer of paint. Next, we're going to install the components. You're going to need cable glands, a 3-phase plug, some 5-core 3-phase wire, cable ties, shrink wrap, some regular wire, a ground spade, some regular terminal spades, a piece of DIN rail, a piece of non-electronically conductive material, which will be the backplate, an emergency stop, an on-off switch, some thermocouples, 2 PID controllers, 2 SSRs, 2 heat sinks, and 2 circuit breakers. Make sure to refer to the circuit diagram to ensure everything is wired correctly. This is an easy but fun part, and this is where it all comes together. So bolt the bodywork in place, and bolt the extraction hood on top, and finally attach the tube for the extraction system. Alright, that's it. That's how you make a sheet press. So here we have the finished sheet press. So switch it on and wait for the plates to heat up. You can close the plates while they're heating up. Put some plastic inside and close the pressing plates. So wait for the plastic to melt and then switch the press off and wait for the sheet to cool down. So you can make sheets with this machine alone. You can find the times and temperatures in the download kit. We recommend having a few things to make the process a bit more easy. Molds, a prep table, a cooling press, and a sliding tool. Having these allows you to heat and cool sheets simultaneously. It also makes the system easier and more efficient to use. You can find out more information about these tools in the link below. Visit preciousplastic.com to find more information. You'll be able to find a download kit that has a bill of materials, CAD models, schematic diagrams, maintenance list, and so on. Also check out the how-tos to find some hacks and improvements for this system. Good luck building.
Oh, and before you go, we just wanted to let you know that Precious Plastic runs on the support of people just like you. Everything we develop is posted online for free and open source, so that people all over the world can tackle the plastic waste problem together. So if you're willing and able to help us, please visit support.preciousplastic.com and leave a donation or find another way how you can help us.